My name is Gustavo Clemente. My topic presentation is about visual analytics. Visual analytics is an outgrowth of the fields information, visualization, and scientific visualization that focuses on analytic reasoning facilitated by interactive visual interfaces. Scalable reasoning systems. Technology to support knowledge transfer and comparative inquiry must offer its users the ability to effectively interpret knowledge structures produced by collaborators. Visual analytics purposes. Visual analytics is a science of analytical reasoning facilitated by visual interactive interfaces. It can attack certain problems whose size, complexity, and need for closely coupled human and machine analysis may take them otherwise intractable. Visual analytics advances science and technology developments in analytical reasoning, interaction, data transformations, and representations for computation and visualization, analytic reporting, and technology transition. As a research agenda, visual analytics brings together several scientific and technical communities from computer science, information visualization, cognitive and perceptual sciences, interactive design, graphic design, and social sciences. Impact on society. Visual analytics integrates new computational and theory-based tools with innovative interactive techniques and visual representations to enable human information discourse. The design of the tools and techniques is based on cognitive design and perceptual principles. This science of analytical reasoning provides the reasoning framework upon which one can build both strategic and tactical visual analytics technologies for threat analysis, prevention, and response. Analytical reasoning is central to the analyst's task of applying human judgments to reach conclusions from a combination of evidence and assumptions. R&D for visual analytics. Visual analytics has some overlapping goals and techniques with information visualization and scientific visualization. There is currently no clear consensus on the boundaries between these fields, but broadly speaking, the three areas can be distinguished as follows. Scientific visualization deals with data that has a natural geometric structure. Information visualization handles abstract data structures such as trees or graphs. Visual analytics is especially concerned with sense making and reasoning. Using vision to think. Visual analytics seeks to marry techniques from information visualization with techniques from computational transformation and analysis of data. Information visualization forms part of the direct interface between user and machine, amplifying human cognitive capabilities in 6 basic ways. Increasing cognitive resources, such as by using a visual resource to expand human working memory. Reducing search, such as by representing a large amount of data in a small space. Enhancing the recognition of patterns, such as when information is organized in space by its time relationships. Supporting the easy perceptual inference of relationships that are otherwise more difficult to induce. Perceptual monitoring of a large number of potential events. Providing a manipulable medium that, unlike static diagrams, enables exploration of a space of parameter values. Scope. Visual analytics is a multidisciplinary field that includes the following focus areas: analytical reasoning techniques, data representations, theories of visualization, visual representations. Analytical reasoning techniques. Analytical reasoning techniques are the method by which users obtain deep insights that directly support situation assessment, planning, and decision making. Visual analytics must facilitate high-quality human judgment with a limited investment of the analysis time. Data representations. Data representations are structure forms suitable for computer-based transformations. These structures must exist in the original data or be derivable from the data themselves. They must retain the information and knowledge content and the related context within the original data to the greatest degree possible. Theories of visualization. Techniques to support production, presentation, and dissemination of the results of an analysis to communicate information in the appropriate context to a variety of audiences. Visual representations. Visual representations translate data into visible form that highlights important features, including commonalities and anomalies. These visual representations make it easy for users to perceive salient aspects of their data quickly, augmenting the cognitive reasoning process with perceptual reasoning, though visual representation permits the analytical reasoning process to become faster and more focused. Conclusion. One of the biggest myths with visual analytics is that it makes discovery easy and faster, which is not true. Although probability of discovering unexpected is niftier, most of visual analytic tools have very sharp learning curve, and it is essential to cover the basics adequately before dividing into advanced methods. Each visual analytics technique is composed of interactive visualization, but not all interactive visualizations are visual analytics. This is a very common mistake to use phrase visual analytics for normal visualization. A visual analytic tool must establish a communication between user and visualization. For every action there should be a reaction, which forces analysts to ask more questions by synthesis of visual reasoning. There is no such thing that visual analytics can be used with only complex and massive amount of data. Visual analytics is a scalable technique and allowed to explore basic as well as composite problems. And that's the end of my presentation. Thanks for watching.